Alright, so we're given an overall reaction, and we're told that we need to find the delta H of the overall reaction. And we're given these two sub-reactions and their associated delta H's. So how are we going to go about this? The whole purpose of giving you the two sub-reactions is that these two here are going to add up to the overall reaction here. And in the process, we're going to have to add these as well. But first, we need to combine these in such a way that it gives us the overall reaction. So the first thing that I see whenever I look at this is I have an SO2 in my subreactions, but I don't have an SO2 in my overall reaction. So I know that that is going to cancel out. In order for it to cancel out, these SO2s have to be on opposite sides of the equation, which right now they're not. So we're going to have to reverse one of these, and you can choose which one you reverse. But I can see immediately right now that, look, this is one of my reactants. Here's my other reactant. So I'm going to reverse this one because right now they're products, but I want them to be reactants for my overall. So I'm going to reverse this one. You could reverse either one, but at the end, when we add everything up, I'll show you how you know if you've gotten it backwards or not. Okay, so let's go ahead and reverse this. So we're going to have SO2 goes to SO2, and our delta H for that. Since I reversed it, now I have to change the sign here. So now that's going to be a negative 296.8 kilojoules. And we're done with this up here. Now this is where your multiplying comes into play, because I have an SO2 on this side and an SO2 on this side, but I don't have the equal amounts. So what I'm going to have to do is multiply this entire equation by 2. So that'll give me a 2 there, a 2 there, and a 2 there. Now we're set up to cancel out our SO2s. But when we multiply the entire equation, we also have to multiply our delta H for that equation. So that figure is 593.6. All right. Now what we're going to do is add these together. We're going to add the equations together, and we're going to add the delta H's together. So these cancel out because we have one on each side and they're an equal amount. Now all we have to do is take everything from the left side of the arrow and add it together. There's only one of these, 2s. We've got a 2O2 here and a 1O2 here. So that's 3O2. And then on the other side of the arrow, all we have is the 2SO3. So we double check that this is the equation that we were given, and it looks good. Now we have to add these together too. So to get our delta H of the reaction is negative 791.4 kilojoules. So I said earlier, it doesn't matter which one you switch here. I chose wisely because I realized that I had these are my reactants in my overall, so I went ahead and got them on the reactant side. That's why I switched that one. But say, for example, you went through this whole process and you found out that you switched the wrong one. You don't have to start over, but if you had switched the other one, everything would have added up the same, except for it would be backwards from what you were given. So instead of us coming out with the right one, we would have come out with the backwards one. And if you went through and did the math, you would also find that the delta H of the entire reaction would change signs. So it would be 791.4 kilojoules instead of negative. So say you got to here and you got this result, and you looked at this and said, oh, well, that's backwards from that. I've done something wrong. I have to start all over. Don't start all over, because all you have to do is switch this back around and then change your sign again. I hope that makes sense.